Is done using geometric transformations such as translations, which we've talked about our slides, reflections, which we've talked about our flips, and then rotations, which we have talked about our turns, or perhaps some combination of these. So where do you think the lizard shown on the grid on the following page will end up using following transformations? That's what we're going to be doing today. A lazy lizard. So you're going to translate the original lizard so that the point at the tip of its nose is located at 2420, making the lizard appear to be sunbathing on the rock.
How did you figure out what it is? You know how right two times? Yes. So I did the same here.
Yes, Magali, that's perfect.
But I put this and that's not where it goes though.
Well, it sort of is because it's over here.
You do it backwards? No, you don't.
Exactly where it is.
Great
job. Magali, I want you to So you can see Magali's picture here. She has her lizard, and then she has her anchor points plotted very clearly, and then she also used the strategy to trace it and then retrace it over here. So Magali, first a question I want to ask you, how did you figure out where the anchor points should go in the image?
So what I did was, at first, it was a little bit complicated, but then I just looked at how many times it went up and how many times it moved. So from here, I just looked at the point of the nose, which is right here, and I just saw that it went up like 1, 2, 3, 4 times into the right too. So I just did the same here, and I went up 4 times into the right too, and I just kept doing that same thing to every other point, which I ended up plotting.
Perfect. So this leads us to one observation about translations, Magali, that translations, the points in the image have to have the exact same orientation to one another as they do in the pre-image, right? Great. So then I asked Magali to connect the points in the pre-image to the image, and you can see that she did that. And then Magali, will you share what your observations were about the lines?
They were
all going. They were going in the, say what you said first, that they were all going in the same direction, right? That's what she was saying. And so this group here, we were trying to decide what is the word that we can use to describe lines going in the same direction. And Andric added that they're parallel lines. And then Victor added that another term we could use for that is they have the same slope. Good. And then Victor, can you share what the slope would have been for these lines and how you figured it out?
Well, what it is, simple, like the rise and run, I guess you can say.
Okay, good.
So you go up 2 and then you go to the right 3, and that's where they meet the line. So if you were to plug in points throughout the line using the slope formula, you will see that it works.
So how did you pick that point to go to?